Here are the reactions. This first reaction is the feed gas. It contains hydrogen sulfide, and so it's reacted with oxygen. This is a combustion reaction. Produces sulfur dioxide and water, as you can see. This needs to be happening at very high temperatures. The second reaction, which happens subsequently in a combustion furnace and also in additional reactors, is the reaction of sulfur dioxide with hydrogen sulfide to produce the elemental sulfur. Below in the bottom line is the overall reaction. There are side reactions. It's notable that carbonyl sulfide and carbon disulfide, along with hydrogen gas, are formed specifically in the thermal stage, which is the combustion chamber. It's also notable, and we couldn't figure out why, but there's ammonia gas that comes with this feed gas. Okay, so this is the overall reaction shown, and these three lines are because there are three different common allotropes. Sulfur can be configured with 2, 6, or 8 atoms most commonly. You can see that this is the conversion from the feed gas to elemental sulfur. The thermal region on the right is the combustion region I was talking about. That's where the first and second reaction happens. You can see that as you increase temperature, conversion increases, but it is the opposite for the catalytic region. You can see the sulfur dew point. The sulfur dew point is important because you cannot go below that. If you go below that, there will be liquid sulfur, and that will deactivate the catalyst for those reactions, and therefore slow the efficiency down. So this is an overall process flow diagram. It's a pretty general one at that. You can see the reactions in the thermal stage. That first box, that is a reactor in a boiler, which water is inserted to produce high pressure steam. There's a subsequent condenser. From this thermal stage, you get most of the sulfur extracted. The remaining sulfur is extracted through the catalytic stages shown. These stages consist of a reheater, a reactor, and a condenser, respectively. They can be produced in 1, 2, or even this can be used with 1, 2, or even 3 of those units. Then there's this is fed to an incinerator. Between that last condenser and the incinerator is a tail process that is often used and will be talked about. This is a straight-through process. The straight-through process, this is with respect to the feed stream. Ignore all the temperatures and pressures. The feed stream can be fed in whole to the combustion chamber, consisting of the reaction furnace and the boiler. This is determined basically if you feed it to feed it in whole through a straight through. It's usually done when the acid, the hydrogen sulfide molar composition is above 50%. If it's below 50%, then you use a split flow process in which 2/3 of the feed stream is redirected right towards the catalytic stage.